Let's have a look at the first classification of experiments into true versus quasi. And I will be using examples from academic papers that comes from my readership. I'm not promoting this journal or that paper. I just think that it is a useful example to give you more context to understand what a true experiment can look like and what a quasi experiment may look like. Let's say you have developed two types of advertisements, and now you want to see which one consumers like more and which one makes them purchase your product more. Naturally, you would like to allocate people to one of these conditions to see which one is more effective. So, what makes a true experiment is the random allocation of participants to one of these conditions. And keep in mind, as you are allocating people to those conditions, you want to ensure that from the beginning they are very similar. So you are not allocating older people to the first advertisement and you're not allocating younger people to second advertisement because that is actually introducing a bit of bias into your research. And the effectiveness of the advertisement is not the outcome of the creative design and its variations in those two advertisements, but of the differences in the composition of those participants. Here on the screen, I don't have a control group, but by any means, you can have one. Having a control group here will actually help you to establish which of those advertisements are more effective when you just look at them. But if you have a control group, it will also show you what is the purchase intention for your product, for your brand will be like if no advertisement is actually shown to them. So a control group allows you to establish what the outcome will be like if there is no intervention, if there is no advertisement one, or if there is no advertisement two. What does this random allocation of the participants allows us to accomplish? Well, first one, it tries to minimize selection bias. And that is important because from the beginning, from the start of your experiment, you are trying to have the groups that are very similar to each other. The example that I used before, where I said, okay, younger people go into advertisement one group and older people go into advertisement two group, is not an example of random allocation. That is me being biased as a researcher. I'm introducing my bias into the experiment, which means the effect that I'm observing in terms of my dependent variable may not be the reflection of the manipulations that I am executing, but of the age variations. The second important purpose behind random allocation is us trying to equalize the confounding variables. Confounding variables are the variables that may impact on your dependent variable. In other words, it is not the effect of your manipulation which are responsible for variations in the dependent variable, but rather the confounding variable. Now, I do have a separate video for confounding variables, but for the purposes of this video, I should say that confounding variables are the ones which may impact on your dependent variable. And in this case, it would mean that the effects that you are observing are not the outcome of your manipulation. They are the outcome of some other variables, which you're not accounting for. So the random allocation of the participants allow us to distribute both known and unknown confounding variables in each group in theory equally. Confounding variables could be, let's say, criticism or skepticism of participants of the advertisements, which means no matter how much you're trying to influence consumers, not all of them will be impacted because some of them may have high persuasion knowledge or skepticism of advertisements, and that will impact on the effectiveness of them. So if you want to balance out that skepticism in the group of your participants, random allocation in theory should allow you to do that. And this is an example of a known confounding variable. There could be something else that we may not be even aware of as researchers as a confounding variable in our participants. Finally, random allocation of participants to one of the conditions allows us to increase the internal validity for our experiment. Internal validity basically refers to us being confident that the effects that we are observing in the dependent variable really and truly occurred because of the manipulations, the interventions that we executed. Now that we've covered a true experiment, and now you know that it is about true random allocation of the participants to the experimental conditions, let's have a look at a quasi-experiment. Quasi-experiment is actually an experiment where random allocation of the participants is not taking place. And very often it occurs in very unique situations. In terms of marketing, that takes place when we are trying to test the effectiveness of different advertisements in different cities or different geographic locations. In this case, people who live in city A, they are allocated to this condition by default, right? They are exposed to advertisement one, and participants who live in city B, naturally, they will just watch advertisements in city B. Now, of course, if those cities are very close to each other, people may travel, so that creates a bit of a problem. Social media could also create a problem because then people who are in this condition, which is aired on mass media, on the TV, played on radio, or executed on social media, who are living in the city, may be viewing also an advertisements that people living in city B. But let's not make it overcomplicated. Usually, you would try to run a quasi-experiment in the conditions where people who reside in city A and city B, they are similar to each other in terms of their socio-demographics, in terms of the market conditions. Because if they are different, it's exactly the same example that I've discussed above. You don't have equal composition from the beginning in your participants. And that means that the effects that you may be observing in sales data may not be the outcome of your advertisements that you tested in that particular city, but they could be an outcome of different sociodemographic or psychographic compositions here. Quasi experiments are also a bit different because here your dependent variable could be different from the true experiment. In this example, because it may not be feasible to go and survey each individual person in this city, city A and city B, you may be just looking at difference in sales data. But again, the choice between city A and city B has to be very critical, very important. They have to have similar respondents or participants in their socio-demographic, psychographic profile living there. There should also be a similar chance for them to purchase your brand, so same amount of outlets or grocery stores, because otherwise differences in sales data that you are observing may not be an outcome of the advertisement that they saw, but just physical availability of the outlets for them to purchase the product. So a lot of thinking has to go into a quasi experiment as well to make sure that the effects you are observing in your sales data as a dependent variable are really the outcome of the advertisement that you are testing in terms of their effectiveness. Again, there is no random allocation in quasi experiment. People who just happen to live in city A will view this particular advertisements, and people who live in city B they will just have to watch different advertisement. There is no feasibility for us to randomly allocate people to those advertisements if we look at geographic areas as a way for us to conduct an experiment. Quasi experiments are frequently used when true randomization is actually not feasible or it may not be ethical. For example, we are trying to evaluate different marketing campaigns, and it's really impractical or not possible to randomly assign customers to different marketing treatments. So in this case, quasi experiment can actually help us to assess the impact of the campaign by comparing CDA to CDB and treating them as groups that naturally receive your advertisement as a treatment. If we are looking at the effect of policy changes, that is also not possible to randomly allocate people to conditions, and it's also not ethical because you are trying to execute a policy and you are trying to see whether it has an impact on purchasing, on economy, any other aspect that you are measuring. And in this case, regions could work as perfect ways for you to test the effectiveness of your campaign or policy. And in this case, quasi-experiment can be the most suitable technique for you to establish the effect of a larger scale of economic, medical, social, or other policy. I hope now the distinction between the true experiment and the quasi-experiment is very clear to you. It's all about random allocation being executed or not executed in your experiment. And I hope you can also see that for some of the problems that you may be facing as a researcher or as a consultant, one of them may be more appropriate. Now, if you're working on your PhD or your research project and you're trying to publish your work, You may be wondering, well, which technique should I be using? If you plan to publish in a journal, I would say journals would love both, because if you will demonstrate that your advertisement produces exactly same results when you invite people into a lab and you randomly allocate them into one of the conditions, and that you observe exactly similar results using quasi-experiment, then it strengthens your research project, because it demonstrates that the same effects are observed when different types of experiments are used. And it also strengthens the overall validity of your project. You may be wondering, well, how should I be allocating people randomly to one of those experimental conditions that I've designed if I'm using a true experiment? There are several tools which are available for us. There are two approaches for you to do it. You can be in charge of it as a researcher if you actually have to have people to come physically to your lab to run an experiment. And in this case, you can use simple randomization. There are multiple tools that allow you to do that. You may use Excel spreadsheets to generate random numbers, and then you randomly allocate them to the participants. You may be using block randomization when you have more complex design, more than two experimental conditions, or you can be using stratified randomization when, again, you have more complex design to start from the beginning and you have more complex sociodemographic compositions in your experiment, and you want to ensure that you capture this when you allocate people to different conditions. All of these types of allocations are discussed in this paper, so you can have a look at it. You can also Google it if you do not want to have a look at this publicly available paper. If you are running your experiment online using online data collection tools or experiment hosting tools such as Qualtrics, there is a randomizer already built in there. In all of those random allocations, what's important is that it is blinded. That means that as a researcher, you don't know which participants go into which condition, or your research assistant is allocating people to the different conditions and he or she is not aware of which is group 1 and which is group 2. This is what's called blinded allocation. You blind yourself because you don't want to introduce any bias into allocation. That's another way for you to increase the internal validity of your experiment. Like I said before, online tools already have random and kind of blinded allocation built into it, because the tool, the online portal, Qualtrics, or whatever it is that you're using, is then itself randomly allocating people into the conditions. Now, I hope the distinction between a true experiment and a quasi-experiment is super clear to you now, and now you can decide which one is most suitable for you in your research.